So we start with very basics of differential calculus. Now, as I teach you this, I understand that you will first what you call study what is called pre-calculus, but this is very odd. You're starting differential calculus first, and then you'll go and learn pre-calculus. So take that pre-calculus out of your mind, okay?
Okay.
That you cannot drive a car before 18 years. Well, the law doesn't allow you to drive, but you can learn to drive. Differential calculus. I will not be interested in what is meaning of differential calculus and all. Today we're going to talk about first thing again. It boils down to the same slope, right? Slope.
Yeah.
Boils down to slope. So let me go down with the very first and easy. Wherever you feel that you have forgotten something, don't hesitate. Ask me and tell me that this part I have forgotten. Can you just narrate it again? So when we talk about slope of a line, so we will typically, let me say that I have a line which is inclined in this manner, right? This is my line, and this is say y, and this is x, and this is my line. So one of the ways to have an indicator of slope is what is the angle this line is making with the positive direction of x-axis. So my green arrow shows the positive direction of x-axis. This is x-axis. X-axis is positive direction. All right. And you can draw this arrow anywhere on this line, and I am interested what is the angle that you are making with the positive direction of x-axis. You can make this angle anywhere. I mean, you want to make this line here, you can make it here also. The angles will be same. It goes back to your grade 7 that in parallel lines, these are known as corresponding angles. So the angles are going to be the same, right? Now, on this angle, the angle exactly doesn't give me any measurement of slope. What the angle gives me is the angle is an indicator of slope. Okay, it's an indicator of slope. Now, what does it indicate? Well, the indicator of slope can be under these different criteria. If the angle theta is acute, I will say that my slope is positive.
Okay.
There is a whole gamut of conclusions about slope. We are just doing it from just a preliminary coordinate geometry perspective. We are not seeing any equations of line or any other thing as of now. Okay. Now, angle theta is obtuse. If this angle theta is obtuse, I would say that my slope is negative. Okay. Now, if this angle theta is 0 degree, that means the line is parallel to x-axis. That means slope is 0. Okay. And if this angle is 90 degree, that is line is perpendicular to x-axis, then I say my slope is infinity. Right? Now, these will get re-verified in our next session of talk. So when you talk about slope, think yourself having a small kiddo out here, and the kiddo slides down. So if it is 0 degree, kiddo doesn't slide anyway. Yeah. Okay. And if you make it 90 degree, kiddo doesn't have a field of slide. He just falls down. So the slide is infinity. You know, at 90 degree, the kiddo can't slide. He just falls down. Fine. Yeah. Right. Right. We go to our level 2 of discussion now. We take the same coordinate system and we take our same line. I'm doing a replica of the previous figure. Okay. Yes. Okay. And out here, I say, let me pick up any 2 points. This is 1 point and this is 1 point. And let's say we try to mark their coordinates also. So the coordinates are somewhat like this, this, and this, right? These are the coordinates. Right. Okay. So we say this is a point P, this is a point Q, and say this is x1, this is y1, this is x2, this is y2. Right? Fine.
Mhm.
And
Right.
what I do is that I join them this side also. And now starts the interesting part. Okay. Now I am allowing you to go from P to Q. Okay. Don't also leave out my theta. So let me extend this to form the positive direction of x-axis also. Right. And this still forms my theta. So I'm allowing, I'm positioning you. You are positioned at P right now. You're positioned at P. Imagine that you are at P. You're at P, right? And you have to reach Q. You have to reach Q. You have to come here. This is your destination.
Yes.
Destination is Q.
Mhm.
And I don't allow you to travel diagonal. You can only travel in x-axis and you can only travel in y-axis, right? Nothing more than that. Ready? That is the condition with you, right? So
Yeah.
one of the way is that if you are at P, now look at my screen because I will erase those. One of the ways that you climb this way and you
Yeah.
just like the rook of chess.
Yeah.
Be allowed to go. Okay, if you say that no, I'm not satisfied going this way, so I will be going first this way and I'll go this way. I don't think there is any other alternative to go to Q by the conditions that I have set for you. So which one
Yeah.
would you like to pick? You want to go first vertical and then horizontal, or first horizontal and then vertical?
Horizontal then vertical.
Okay, you want to go horizontal first and then you want to go. So if you want to travel horizontal first, this travel is known as run.
Mm-hmm.
And which side you are running? You're running towards positive x.
Mm-hmm.
So in this particular criteria, your run is positive.
Yes.
You're running positive side, right?
Yes.
And then you have to climb from here till this part. Okay, sorry. You have to climb from here till here.
Yes.
And I would call this as your rise.
Yes.
And since you're rising north, sorry, since you're rising north, that is towards the positive y, you're rising north, your rise will be taken as positive hit here.
Mm-hmm.
And first time we will be coming and concluding on the formula for slope. In the previous diagram, we only had in the previous diagram, let's mark them. Let this be 1, let this be 2. In the previous one, what we did was an indicator of slope. And the second one, we are computing slope. So we slope is always given by the ratio of rise over run. Okay. It is given by the ratio of rise over run. And don't forget that whatever you're taking rise or run, you should also consider their signs. So for this example, it would be a positive rise because you're rising north, followed by a positive run. Does it make it a little bit clear for you?
Yes. We're going to pause while I write things down.
Yeah. But before you pause, I'll just make one diagram and then I'll allow you to. I'll pause. Okay. Now I'm one more diagram out here. Okay. And in this diagram, I deliberately make my line in this manner. Okay. And I ask you in the same way to pick up 2 points, which you have picked up out here. And can you tell me how would you like to go from P to Q out here? Tell me, you make your choice.
Go down and then go.
From P to Q. You want to go from
P to Q. Oh, go up and then go left.
Go up and go down. Okay, so I think she wants to go this way and wants to travel this way. Okay, if that be the case, I would say that you are rising north. Okay, you are rising north, so your rise is positive, but your run is towards x dash, so your run is negative run. Okay.
Yes.
I will conclude that your slope is equal to a negative run.
Rise over run, sir.
A negative, sorry, 1 minute. Sorry, it's a rise over a negative run, which means it is ultimately negative. Okay.
Yes.
And don't you forget what I taught you very first, that my positive direction of x-axis is this. Okay. And if I now try to have a slight look at my, if I try to have a slight look at my theta, this is my theta, I would say obtuse. I would use my formula that if you are obtuse, this particular formula, that if you should be negative, and exactly it's tallying on both sides. Do you agree that? Okay.
Yes.
Theta is obtuse. Since theta is obtuse, it should be negative and got negative. That concludes our first part of discussion, how to interpret slope and what is the generic formula for slope, which actually brings us to a writing break and a banana break for 1 minute. Can I slowly scroll up?
Yeah, you're fine to scroll.
And can I use my stylus to write two things, or you're still writing?
I'm almost done with writing. If you want to get started, you're fine.
No, you finish it. I want your apt attention, because if you understand this once, then your classes will become very easy. It's easy to tell you a formula and start jabbing that formula into you and going with the problem, but that does not give any, it will not give you satisfaction knowing you. Once you know how it is coming, it makes life easier for you. And we are here to make life easy, not hell. Right. 1 and 2. So I'm just writing 3 as you're getting ready.
Okay.
Anyway, these are made in nice manner, so this will anyway go as PDF to you, so you need not worry. Okay, now I'm on 3, and on 3 I'm going to see one more scenario out here where I'm making my line now. I'm making my line with positive direction of x-axis parallel to positive direction of x-axis. Now, where is my positive direction of x-axis? My positive direction of x-axis would be this. Now, you may say, sir, why are not taking 180? We take the smaller angle. So the smaller angle is 0 degree. Okay. So out here in this case, I would say that my theta is equal to 0 degree, right? Theta is equal to 0 degree. Pick up 2 points out here as usual. So we pick 2 points out here and we name these points as P and Q. And you are to reach Q. Okay, you are to reach Q. So you will agree with me that when you try to reach Q, you do have a run, but you have no rise, right? Can I write here? I say that your run is positive from your trying to reach from P to Q, but your rise, you have no rise. Your rise is equal to 0. So you may calculate your slope, and your slope is rise over run. Rise over run. So it is 0. Which actually satisfied what we had written there, that when the line is parallel, it's 0, right? Fine. And then what we do is that we make a line which is perpendicular. This is the line which is perpendicular, and it's perpendicular to what? With the positive direction of x-axis. So there's my positive direction of x-axis here. And nothing stops me from concluding that theta in this case is 90 degree. And I pick up 2 points of my choice out from here and here. And I name these 2 points as P, and this point is Q. So if you see now, do you have a run? Yes, you do have a run. And I would say, yes, a rise. Yes, you do have a rise, and your rise is positive, but you don't have a run. If you run, you are out of this line. Yeah, the run is 0. So if you try to compute slope in this case, it is a rise over run, a rise over run. And you come in indeterminate form where you have a rise and you have a 0 at the denominator, and you are forced to conclude this as infinity, which satisfies our 4 observations which we did. So does that make things a little bit, easy for you to understand and comprehend about slope? Now what are you doing? You have married the slope with formula so far, and you have also married the concept of slope in terms of the indicator, that is the angle. The angle only gives me an indicator, positive, negative, 0, or infinity, and the angle, the ratio gives me the formula. The ratio gives me the value, that is rise over run will give me the value. Now, since you are a line, it would be foolish on our part to ask what is slope at P and what is slope at Q, because the angle at P and Q do not change. It's a line. Are you getting what I'm trying to say? There is no point in asking when the graph is a line. When the graph is a line, never ever ask what is the slope at P and what is the slope at Q. That's a foolish question, because Our angle is
It
always,
will be the same at both
yes,
points.
if an angle is an indicator. So if the angle is same, obviously the slope is same.
Mhm.
And after that, if you don't understand anything, don't you forget the lovely kiddo who is on the slide. He doesn't feel an inch of a bumpy ride as he slides down a line. There's no bumpy ride. He slides down uniformly. Have you understood here? Now
Yes.
we know the formula of slope. We know the formula of slope. And let me draw one more figure and make it our fifth analysis. Our fifth analysis would be something like this, that, sorry, my fifth analysis is, and I'm taking the positive slope as my illustration. Okay, my fifth analysis would be that I take my line and I select two arbitrary points on it, that's P and Q, and all you did was that you tried to find the rise over run from P and Q. So you were interested in this, you were interested in this, and don't you forget the positive direction of x-axis. Well, the positive direction of x-axis is this, and then what is my theta? This is my theta. Then definitely this is my opposite side, and this is my adjacent side. So tan of theta is equal to opposite by adjacent. Isn't tan of theta same as rise over run? This is also slope. Now you have a formula for slope, and you have married the formula. A little bit of trigonometry, you can't forget any of those. The devils haunt you everywhere and there. And so tan of theta is also known as my slope. I think this gives your face and your smile tells that it's a eureka moment for you. So why don't you copy number 3 and number 4? That's rise over run. Okay, so we have done this.
Yes. Okay.
Interesting?
Very interesting. I forgot about tan theta.
Yes, you forgot. So tan theta, if you forget, then always remember tan is TOA. TOA comes from SOHCAHTOA.
Yeah.
Yes.
That I won't forget, don't worry.
SOHCAHTOA, and TOA comes from TOA. Okay, one of the, as you keep on writing, see, you need to understand one thing. As long as it is a line, wherever you compute the slope, there is no point in asking what is the slope somewhere else, because the slope of a line is always constant. And we conclude this at the end of this chapter or today's discussion with something more interesting. So can you just copy this part and let's see.
Absolutely. Give me a sec.
Yeah. But you are copying this, you will get this lovely PDF also with you. You can keep it.
Oh
right?
yeah, I would like the PDF doesn't put it in my head.
Okay, so your head always understands what you do. Good interpretation.
See, because once I write it down, then I won't like forget
You're
it.
not writing it down, you are learning it. Writing it down is somebody like a parrot would do. You're not writing it. You are understanding and writing. That's why your learning is reinforced. Kinesthetic approach. You're doing it on your own.
Okay. Yeah, we're good.
So, you know, 2-act plays. This was Act 1. And now we move to Act 2. In Act 2, it will be somebody else's house, somebody else scene. So Act 2. And Act 2, we try to give a concept to you about what is limit of a function. Totally swapped from slope. Now slope is getting parked aside. Limit of a function. Okay, let's understand what is limit of a function. Let me say I take a function f of x is equal to, say, 3x squared plus 2x plus 5 divided by x minus 2. Got it? Now, you'll write it later. Pay attention. This x minus 2. Now, this is an incomplete statement from my side unless and until I specify the criteria that x is not equal to 2, because at x equal to 2, this changes to an indeterminate form, that is by zero form, and it becomes not defined or infinity. So I don't. Why I need to specify this? You need to ask, sir, why are you specifying this? If I don't specify this, then can I evaluate what is f of 2? I cannot evaluate. I will write that f of 2 is D and E, does not exist, because once you put 2, this goes into an indeterminate. But when you write this, you put an anticipatory bail that, look, the domain is such that, I would say, the domain of this function is such that x belongs to all real numbers. It's a real valued function. You have a polynomial function on the top. You have a polynomial function at the denominator. X belongs to all real numbers. X cannot take the value 2. I have specified it. Does this make clear? I don't know what is the function's value, right? Now the question comes. It's something like you quarrel with somebody and that somebody does not have the right to hit you, But the law does not stop him to wave his hand just in front of your nose. I'm still not hitting you. My job is to give you the irritation. Hitting you will be irritation. Like when you fight a small brother and say, don't touch me. Okay, I'll not touch, but I'm just going and doing this in front of you, this. Irritation is same, but within the law. The law says, don't touch me, I'm not touching you, but I'm irritating you. And we still find the value of f of 2, though we are not allowed to take 2. What if I tell you, can I find the value of f of 1.999999999? Am I not irritating you? I'm irritating you, but within the law? Yes, within the law. Can I get a value? Oh, yes, function is defined for this value. You can't say no. Or alternately, I tell you that f is equal to 2.00000000001. Am I allowed to do this? Yes, you can irritate me. Now, in both the cases, if I try to look at the number line, okay, if I try to look at the number line, which is something like this, and in that number line, we have a marking out here which stands for 2. This is 2, right?
Yes.
When you are looking at the first iteration from my side, when I'm trying to irritate you, I am actually trying to proceed 2 from this side. And when you see on the other example, I'm trying to proceed on this side. So I say the function does not exist at 2. So what do? I say, let me put a hollow circle at 2, because at 2, the function is not defined. Yeah, it's not defined. But nothing stops me from defining the function just before 2 and after 2. So there, I need to now know, I need to quantify, or rather should I say, I need to bring a word or some expression as to the way I'm irritating you, in which I'm legally valid and you are equally irritated. So my mission is solved. But what do I call this process? Should I say function value? So there is something called function value. You will say that, sir, you can't use that because, you know, at f of 2 function is not defined. Then I say, I will use a word called limiting value. Limiting value of function. Now, this is very, very interesting. Function may not have a value, but the limiting value of the function always exists. I won't touch you, but I will irritate you within the law. And this side is called the limiting value of left-hand side. So it's called the LHL, or the left-hand limit. You may expand it when you're making your notes. And this is called the right-hand limit. Right? And I would say that though f of 2 for this particular example is D and E, there is something which I can still find, which is limit of fx, the function. What is the limiting value of the function as x tends to 2, as x tends to 2. And this x tends to 2 can happen from 2 different sides. One is the left-hand limit and one is the right-hand limit. And how do I write it? I write the left-hand limit as limit of x tends to 2 minus f of x. Now, many children think x tends to 2 minus means negative 2. No, 2 minus means you are approaching to, suppose your flat number is 1303, you are approaching from 1301, 1302. That's 1303 minus. And the right-hand limit is specified by limit of x tends to 2 plus f of x. It means you are approaching your flat from 1305, 1304, 1303. You understand?
Yes.
Be clear. Can you absorb one more minute, or you want to write down? Your wish.
I write down.
Oh, pens down then. This girl will never make me teach in a flow. That is her problem. But I can't help it.
Yeah, would you rather teach in a flow or would you rather I understand?
No, I'm more interested in you understanding what is the point in me teaching in a flow. And
Exactly. So then you can't complain also, no?
yes, but you know that the itch is equal on my side also. So it's like narrating a horror story to somebody and then the door opens. Can I just drink water and come? Hey, you're like that. Okay.
I mean, yeah. I thank you. I take great pride in being like that. वो कहते हैं ना, no touching, just irritating.
No touching, just irritating. Yes, you can still hit me within the law. What an approach. You have not learned ABCD of pre-cal, you are learning calculus. Good.
Exciting. It's okay. समझ आ
Understood
गया तब तक.
so far?
Yeah, I'm getting it. Let me write stuff down and then we can move
Yeah,
on.
why not? You please write stuff down. This is Act
Mhm.
2. That was Act 1.
Mm-hmm.
No, we'll get back to our slope again, huh? Don't forget the slope.
Yeah, I will never forget slope, sir. वो तो मेरे
Slope is just parked aside like boiled noodles, which have been washed in cold water and put on a spreading platform. Meantime, we're chopping some vegetables on the other side. So don't laugh at that chopped onions. You are also chopping onions out here.
Wait, so are limiting values like the value of
The
the
value
function?
closest to F2. The value closest to F2.
Okay.
Have a value at F2. What is the price of this camera? Nowadays, camera is the only thing that is hovering on my head. So the example is, what is the price of the camera? Can't say exactly. Okay, some guess, some ballpark figure. This is that ballpark figure. But you can't remember the sticker price or the list price or the label price. And the law says that if you say something wrong, you face a penalty. So why would you like to take a risk on committing something on the sticker price or label price when you don't have a concrete knowledge about that? So what you're going to say, you want to say some ballpark value, and you're putting a anticipatory bail before that. Don't get me wrong, huh, sir? It's around something $230. I'm not sure, by the way. It may not be the label price. So the limit is not the label price. It's your ballpark figure to the best possible estimate. Makes that sensible, clear?
Yes.
Yes. Right. My hands are itching to go to the next thing. You stop me in between now. I'm just trying to think. I should not forget from where I should start.
Self-control, sir. Self-control.
Control. Oh yeah. Now how
exactly.
do you just see how to write limit? By the way, I am writing it as LT. When you go to calculus, you'll find your printed books are writing LIM.
LIM, yeah.
Yeah. So you can put LIM also, as long as it makes sense for you. I won't be evaluated for an exam again. I'm too old for that, but you don't make a mistake.
I won't, don't worry, sir. I never make mistakes.
No, if you write LT also, it doesn't make a difference. LIM and LT are all same, it's limit.
Clear?
Are we done?
I'm good.
Are we done?
Yes, we're done. Let's go.
Okay, so this doesn't mean that limit, okay, for limit of x tends to say some number A, okay, or let's say x tends to a number C, f of x to exist. It doesn't mean that limit value will also exist. For this to exist, the criteria is that limit of x tends to C minus should be equal to limit of x tends to C plus f of x on both sides. Now, don't mug it up. Just try and understand. You will think, sir, how can these two be same? Please understand that from C point, if you are approaching from this side or you are approaching from this side, I'm making that small, infinitesimally small means your deviation from C on either side is very, 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 very small. So many varies, I've said. So if it is, say, C is the 0.5, don't say that you are coming from 1 on this side and you are coming from, say, 7 on this side. Any fool will say that the values will never match. You are at 4.999999999 and 5.000011111. They will be almost equal. That is the basic of calculus, as we say. So the limit, the left-hand limit has to coincide with the right-hand limit. Okay, the left-hand limit has to coincide with the right-hand limit. a little bit detour from our original discussion, but still, because I've said this, this will help in your mathematics also. So left-hand limit has to be equal to right-hand limit for limit of a function to exist. You've understood this? Okay, very good. And you may also ask, sir, how to find the limiting value? Well, suppose I tell you that f of x is equal to 3x squared plus 2 plus 1. And I tell you, find out the value of f of 1. You say that what kilo jobs are you asking me to do? You just do 3 into 1 plus say 2x. And you say 2 into 1 plus 1. That's f of 1.
Yeah.
And I ask you, what is the value of limit of x tends to 1 f of x? You say that the value is nothing but 3 into 1 square plus 2 into 1 plus 1. It's just the same. So in limit, what we say, substitute the tends to value as long as you don't land up in indeterminate form. As long as mom is not watching, you can watch anything. As long as you don't land up in indeterminate form. You can, otherwise, go ahead and substitute. This typical function was what? This typical function was a function in which we were having, what were we having? We were having something like, you know, a rational function with 1 as the denominator, right? I change my example and I bring it like this. Fx is equal to x squared minus 2x and say plus 2. Okay, x squared minus 2x plus 1. And I put a value here. I say this is x minus 1 right at the bottom. And I tell you that can you now this I have, when I write this as a function, I would say x is not equal to 1, obviously, otherwise it will become indeterminate. Now I ask you, find the value of x tends to 1 f of x. Now this particular law gets valid for you, that you do not have the freedom to substitute. You cannot do this, right? You cannot do this. Cannot do this. Why? Because if you do this, you land up in indeterminate.
Okay, wait, hold on. I thought limits were to like figure out where.
Yeah, so limiting value. So limited. So limit value is like put the value. When do you come to limit? Okay, first of all, the first question comes, if a function value can be exist or does not exist. If it exists, there is no question of going to limit. Why would you? If the law allows me to hit you, why should I just move my hand in front of your nose? I'll hit you. When the law does not allow me to hit you, then I take the limit approach. Then you take the limit approach. And limit approach means you should find what is the limiting value. You have to calculate the limit value. And the limit value will be the same thing that I told. What is how to calculate the limit value? By this formula. Substitute. As long as you land up in indeterminate. If you land up in indeterminate, then there is lafra. You have a problem. What you are right now landing up in. Now, if I ask you to find out limit of this value, say if I go ahead with this step, I would say limit of x tends to 1. I'm trying to find the value of x squared minus 2x plus 1 divided by x minus 1. I'm stuck up now. I can't substitute. If I substitute, then it takes me to the indeterminate form. Are you understanding what I'm saying?
Right. I think so. Yeah.
No, it cannot be. I think so. Once again, I'll tell you. Okay, let's. Wait. Suspend judgment. F of x is this.
Yes.
It's a normal polynomial function. To be more specific, it's a quadratic function. Does that make sense to you? I ask you find the value of f of 1. You say you're asking kiddo stuff. You just do it and you found the value of f of 1. So you are in this route. You don't need a limit approach now.
Yes.
Now I try to play smart with you and I give you this example. I ask you find f of 1. Then and I tell you that x cannot be equal to 1. So you're here. DNE does not exist. F of 1 does not exist.
Yes.
Now, if it does not exist, the law doesn't allow me to hit you. So I will now move my hand in front of your nose and irritate. So I have to take the limit approach. So if you take the limit approach, you write limit of x tends to 1 f of x. All understood? All understood, sir. But end of the day, what is the limiting value? So you say that, sir, you said that I am free to substitute the value and calculate just like a f of 1, as long as I don't land up in indeterminate solution. So let us substitute f of 1. You put a 1 square out here, you put 2 into 1, you've got a 1, but you are an indeterminate. You cannot put f of 1. You can't substitute the limit straight away. Have you understood now?
Yes. My question was more like,
Hmm.
how do I word this? Hold on. Why does that law exist if you're only doing limits to figure out when you hit indeterminate form?
Why does that law means which law?
Like this, like substitute values as long as you don't land up in an indeterminate form.
Because
Why would
end of the day, you need a value. Maths does not give you a value when you are an indeterminate. When you are by zero,
Right.
what is the value? That's indeterminate. That is DNE.
Right.
That is
Right.
infinity. I need a value. I need the price of the camera. Some ballpark figure you need to give me.
Right.
You are unable to give me here. Neither the function value, neither you remember the limit, the label price of the camera, not you are able to say what is the ballpark value.
Right.
Of the competitor, but you are my salesperson. What am I paying the salary to you for? Unless and until something you say from your mouth, you're as good as to be fired from my team. As simple as that. You don't have any information of the market, right? Then you say, hang on, sir. If it is like this, I can still do some buy, beg, borrow, steal. What do? You say limit of x tends to 1. You convert this to x minus 1 whole square divided by x minus 1. I can do that. A square minus
Holes.
and then what do? You cancel this with this, and now you are left over with limit of x tends to 1, x minus 1. You happily substitute it and you tell me the ballpark figure is 0 because you are not landing up an indeterminate. Yo, girl, do you understand this? So in limits, we are allowed to substitute the value as long as we don't land up in indeterminate. Why did you take the limiting route? You took it because you don't remember the label price. You don't remember the function value. Rather, you don't know what is the function value. So in order to have a secondary approach to the function value, you take a limiting value approach. And in that limiting value approach, you may hit this hurdle again that you land up in an indeterminate. Then the rule is buy, beg, borrow, steal. You have to get out of that indeterminate form, whatever way. And that is all you will learn in the chapter of limits when you do calculus. Different algebraic techniques to kill the ambiguity that results due to an indeterminate form. You have to just clean the function, remove its indeterminate nature, bring it to a nature where you can substitute the limit values directly and you're done. Did you understand this part?
So remove the holes essentially, and then
not remove the hole, remove the indeterminate nature. Otherwise, you can't plug the limiting value.
Okay. Question. What if you can't remove the indeterminate nature? Like
you will be able to. That is all calculus about. There is. However, there are some functions where limiting values do not exist. Even the limits will fail. Specific criteria that we will not discuss now because our target is to go to physics now. But you will be able to find the limit. It means I will tell you that you will come to a position where you can plug the limiting value. Means the limit, the point at which, not limiting value, the point at which you are desiring to find out limit, you will be able to do. There are different tools and techniques, and that's your test on that chapter. When you will be tested in that chapter, how good do you know factorization? How good do you know rationalization? How good do you know? And then if nothing works, then there is one great thing called L'Hospital's rule. You can apply L'Hospital's rule and you can actually do everything. So have you understood this? How this was all about your idea, and just a little bit of detour now, So what we do is that we have a lovely little pendant. Okay, we have a lovely little pendant, which is actually hanging on a nice pearl necklace. What necklace? Pearl necklace. So let me make the pearl necklace. Okay. Wow, what a lilac is the color of the pearls. Okay. 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 But the beautiful lady who is supposed to, put on this necklace is unfortunately blind. However, nothing stops her from, decking herself up. So she goes to her closet, she opens her box of pearl necklaces and picks up the pearl necklace, but she has not worn it for a long time. So obviously, when you try to wear a necklace for a long time so that you don't have a oops moment and all, you would like to check whether the necklace is still not torn anywhere, right? Now, my question to you is, what is the most common way to check whether a necklace is all intact or is it torn somewhere? Some bead is torn or it's
Go through all the beads and like feel them.
okay. Can we be more a little bit easy on that? I mean, this is my pearl necklace. I think I'll just hold it and just pull it once and see if it's intact. Pull it and see. Right. Now, Our Lady wants to see whether the pendant is also intact, and she is blind. She's blind. Okay. Now, all this must have some relation to calculus. Otherwise, why are we talking? So, the pendant is the necklace is now something like f of x, the graph of some f of x. The pendant is at a position x equal to c.
Right.
X equal to c. Now she wants to see whether the pendant is intact or not, and she thinks that let's have calculus in this approach. So whether the pendant exists or not, what does the lady check? The lady checks whether f of c exists or not. Are you understanding?
Yeah.
Easy. F of c exists means the pendant exists. She's
Right.
blind. She's blind. God has not given her sight. So she checks f of c is there or not. Pendant is there. Nobody has stolen, and the pendant is quite costly, right? Like the dinosaur earrings of yours. And then she wants to check whether the necklace is continuous on the left hand side. So she checks limit of fx as x tends to c minus. Right?
Right.
And then she wants to check on the right hand side, because this thing is going to end up in a S sort of a hook, and this thing is going to end up on that circle, which she actually hooks her up on her neck.
Yeah.
So I'm fine. Okay, very good. So she checks on this side. She's basically applying limit of fx x
As
tends
x
to
tends to
plus,
c.
and she arrives saying that, and she tells her husband or whatever, you know, honey, f of x tends to c minus f of c, and limit of x tends to c plus f of x. I just want to check, and I found all of them equal. My necklace is intact. And welcome to calculus. At that case, you say fx is a continuous function. Wow, Trisha, what a nice way to learn. It's a continuous function. It's not discontinuous. And continuous from where? From the interval a to the interval b is a continuous function in the closed interval AB, where the hook, S hook, and the circle hook both are included. These are the two intervals. Go out to the market, and if you get one book that teaches you continuity like that, bring these scissors and chop off my ears with the way you want. I bet. When I say I bet, I bet. You'll never forget what is continuity.
No, seriously.
Yes. So continuity of a function is like a lovely, beautiful lady cross-checking her pearl necklace, whether the pendant is intact or not, because you know, limits of both the limits should be same, then limit exists. And they will equal to the function value, almost equal to the function value, if the function is defined. Now, definitely the function should be defined at x equal to c. Here, the function is defined. Don't think that it's an indeterminate case. The function is defined. So if the function is defined, the left-hand limit just merges with the right-hand limit, and she finds the pendant also. And she says, I think my pair of pearl necklaces are still intact the way you gifted me last over Christmas. And that's a continuous function. And continues from where? From the S hook till the circle, where you will actually hook it up.
Yes.
Make sense?
Absolutely.
You can copy.
Okay.
And you can make a better picture of the lady. She looks to me like a pigeon's head as of now out here.
No, yeah, I was gonna say she looks like a crow.
She looks like a crow, so we need to make her a lovely lady. Wait, let me make that also. Don't you tell that your sir doesn't know how to draw. Impossible is a word found in the dictionary. So we'll make her look like that Spider-Man's Daily Bugle lady. Well, Spider-Man, where are you? Whoa. So curly hairs. And she's smiling. Unfortunately. ठीक So you learned what is slope, you learned what is basic idea of limit of a function, and you also learned how to, this is grade 12 stuff, by the way, okay, continuity. What is a continuous function? A function fx, a real valued function fx, defined within the interval a to b, is said to be continuous at a point x equal to c if the left-hand limit and the right-hand limit are equal, which means the limit of the function exists, and that equals to the function value at that particular point. Then we say that the function is continuous. Otherwise, the function is not continuous. And would you like to hear a layman's definition? But that is there in every good book of calculus. A function is said to be continuous if while sketching its graph, we do not remove our pen's contact with the paper.
Yeah.
If your hand moves up from the paper, the function is discontinuous. Otherwise, the function is. Look at a sine function. When you make a sine function, you don't move your pen from the paper. Na, 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 na. It's a continuous function.
Mm-hmm.
And if a function has got a point of discontinuity, then what do? You have to lift your pen from there and again put your pen. So, sir, why are you doing all this crap? We could easily use our pen. But do you know the graph of every function? No. But, sir, we are blessed with TI-94. We can plot graph. Oh, yes, then you can do. If you have a TI-94, then you can follow the graphic approach, but that's not always possible. So we have to.
Yeah, that is not always possible because
yes, that's not always possible.
Calc and pre-calc. I don't know about pre-calc as much, but I know calc first sem is almost fully no calculator.
No calculator, so they'll not give you calculator. So graphical analysis fails out there. You need to have an alternate, and the alternate is very easy.
Calculator के बिना क्या करेंगे?
Calculator, you won't get numericals to do. Calculator नहीं चाहिए.
Mm-hmm.
So our act 2 ends here.
Mm-hmm.
Act 1, act 2. And now we'll have a combined act.
Okay. Hold on. Give me a second, then we can go to the combined act.
Yes. But absorb the combined act till the moment you are able to absorb. Don't overeat, else you'll have indigestion. Don't overeat.
Mm-hmm.
Absorb it till you can absorb.
Mm-hmm.
Find the absorption is going a little bit beyond head. Don't you do that. Don't you do that.
Okay.
You understood?
Yes.
Okay. Now, why are we marrying these two? Now, act 3. Act 3, act 3, act 3, act 3. Act 3, we go back.
Mm-hmm.
Let's say we have a function y is equal to fx, and the plot of the function is somewhat like this.
Mm-hmm.
Non-linear. You know, right? Linears will always have a straight line. This is a non-linear function, right?
Mm-hmm.
Non-linear function, y equal to fx. And I bring my clause back to you. What is the slope of fx? Then you said it's a question that you are asking doesn't make sense because the slope itself is variable.
Mm-hmm.
Why? Okay, bring our lovely little kiddo. Doesn't he slide very fast from here to here? Put him here. He slides a bit slow. Here, he slides the slowest. Maybe here, he'll just go reverse direction. His slide is different in every position. Do you agree or not?
Mm-hmm.
Right. So, but I have asked a question and a teacher can never be wrong, whether you call it, that it is injustice or whatever. So the teacher is correct. So you need to make the teacher correct. So the teacher tells you that what is the slope of fx at x equal to c? Every point has got a different slope at x equal to c. Then you tell me, sir, first plot c for me. Okay, this is the point c. Excellent. This is the point C. And I need to find out what is the slope of the graph at this point, x equal to C.
Mm-hmm.
At x equal to C. Right. So say this is x equal to C and this is f of C. Why? Mm-hmm. Because this is y equal to fx.
Mm-hmm.
Clear?
Yes.
Now we don't know what it is. So you say, let us take one more point because you remember only the way I taught you by rise over run, and you take one more point and you start naming them as P and Q. And you say, sir, life about a slope is very easy. You just calculate rise over run. Okay, or you calculate what is known as tan theta. Okay, very good, tan theta. So this is the positive direction of x-axis. Let me make this with yellow, or else it looks very dirty fellow. Like this is my point. Or sir, you find a angle. But how does a curve make an angle with a line? PQ is not a straight line. PQ is a curve. How does a curve make an angle? Then you start thinking, that means you mean to say, sir, that rise over run doesn't work here. No, lady, how does rise over run work here? Because if you want to apply even tan theta, it should be a right angle triangle. It's not a right angle triangle. The hypotenuse is a curve. So you start bringing another new concept and you said, oh yeah, sir, you had taught all these to us if it would have been something like a straight line like this, right? If it would have been a straight line, I would have been able to apply to you. So when you try to work out the slope at P, all you will be interested is how can PQ become a straight line? PQ is not a straight line. If PQ is a straight line, my job is done. Rise over run.
Yeah.
Okay. So what do you say? You said, sir, I have got one more technique, and I'm pretty smart at those things. I start bringing Q a little bit closer to P. Okay, I said, well, very good, daughter, you can do that. You bring Q out here and you say, I have now shifted Q to this point. Don't you think, sir, PQ is looking like a line? Okay, then I said, very nice. Let us do some more analysis on that. So our girl has brought Q to this point. And I would say that the difference that she's maintaining between x equal to C and Q, the difference she's trying to maintain here, I'll say this distance is, say, a value which is known as H. Make sense? So
Yes.
this point is x equal to C plus H.
Yes.
And then obviously, I have no other option, but I would say that this is f of C plus H.
Yes.
Right? And she says, now look, sir, now it is rise over run will work. PQ looks like a straight line. And we can form a right angle triangle, whether you want to go by tan theta or rise over run, it does. I said, are you kidding me? And I expand this diagram, although this is not a touch screen for me like before. If it had been touch screen diagram, and if I bloat this up, you will again see that on a magnified vision, PQ is still not a line. It cannot be a line because it's a curve, it's a curve, it's a curve, it's not a line. Do you agree?
Yes.
And then you start telling me, okay, bring Q more close. Oh, you try to play that game with me. Bring Q more close. Now is it not a line? I said, no, it's still not a line. I've loaded. Then you said, fine, bring Q more close. I brought it more close. Now is it a line, sir? You can't deny. I again bloated. At that moment, you are ready to tear your hairs apart and you say, I don't know what you do with your screen, but there is some point Q at which it is so close to P that it almost appears to be a straight line. Then I can't deny you. Although both of us with our eyes cannot see that point, but there is legally a point. There is legally a point. If you walk from your house to your neighbor's house, then you feel you're walking a straight line. But somebody observing this from Uranus says that, look, this girl always walks along a curve because you're on part of the earth. But there is a straight line. Hold on, Tusha. Just your sleep and everything. Just hold on for next.
No, you're fine.
Just hold on. So there is a point. Then I tell you, I agree to what you say, Twisha, but how does the court of law accept what we say? You say, sir, you make some rule, give some gizmotic definition, but that slope exists. Then you say, okay, let us do one thing. All Twisha is trying to say is that H should be very, very small. Because if this is true, then P and Q are close to each other. Close to each other, provided P is not equal to Q. They don't merge, they're just close. And if this is true, then this is true. If this is true, then this is true. And if both of them are true, then on the third point, I can say, then my PQ almost is a straight line. And if that is true, then I can say slope is equal to rise over run or tan theta. This is the story. This story now we have to make it gulpable to the court of law. So we calculate rise. Our rise would be f of c plus h minus f of c. Do you agree? This is our rise.
Yes.
Our run is only h, that is c plus h minus c.
Yes.
Only h.
Yes.
Or would you like me to write as c plus h minus c? We have understood.
No, h is fine.
Now, what all did we specify? We specified this. We specified this, right? Somehow we need to specify this. And in order to specify this, act 2 of our play to the limit h tends to 0, h is not 0. If h tends to 0 means h is very, very, very small, then it is this. And you would call this something as rise over run. And these rises are very, very small rise. This is not a rise which is you can see with your eyes. So let us say it's a rise on what? The y-axis. Very small rise. Delta y. And a very small run. Welcome, girl, to calculus. You just found out the definition of what is dy by dx. Doesn't that be smooth? This is dy by dx. So if you would have calculated, sir, what if I would have calculated without the limit and would have calculated f of c plus h and then f of, now I'm removing the word c, okay? And I'm going generic. I'm removing the word c and I'm going generic with a function. Hang on a minute. I'm going generic. Then I would write like this, that limit of h tends to 0, f of x plus h minus f of x divided by h is nothing but which gives me dy by dx. Where this is dy and this is dx. Agreed? This is dy by dx. And you tell me, sir, if I would not have used the limit and if I have used only f of x plus h minus f of x divided by h, okay? That means you are seeing a ratio of difference in x-axis, y-axis over difference in x-axis without the limit.
Yeah.
Obviously, we can't call it a slope. We won't call it a slope because now if you don't put the limit, it is not a hypotenuse. It's a part of a curve. I call this as delta y by delta x. This is the bigger brother. The differences are still quite big. So they are not d. D is del y. This is delta y. Delta y thoda is bigger. Do you get it? This is delta y by delta x. So many people say that slope is equal to delta y by delta x. I would say slope is not delta y by delta x. This is not correct. It can be correct only when you introduce a limit and say delta x tending to 0. The x should be very. Then you can say that this is equal to slope. If you introduce, if you don't introduce, then it's a delta x by delta y. Yes, the value can exist, no doubt about that. But you have to put. So if I want to rewrite this, how do I rewrite this? I take off all of these and I say, is this equal to slope? My question is this equal to slope? You say, no, this is not slope. Then what is slope? You would say, slope is equal to delta y by delta x only when delta x tending to 0. Whether you are a linear curve, quadratic, this is a common thing. It holds for everyone. That means the difference should be so small. End of the day, remember, this is what the books do not write. And I would want you to write, hypotenuse must be born. Must be born. Because only then you can apply tan theta equal to rise over run. And only then you can calculate slope. Then you say this is slope. And then why will I write such a big definition? Why will you write such a big definition? Okay, write a smaller definition. And the smaller definition would be slope is equal to dy by dx. Where dy by dx is a ratio given of delta y by delta x with the condition delta x tends to 0. And then you will tell me that, but you said, sir, end of the day, what are we looking at? End of the day, what are we looking at? We are trying to find the slope of a curve now, not the slope of a line. We started all with this thing, Prashant. Just remember, we started our whole story with something like this, right? And this was y equal to fx. And we started our story taking an arbitrary point C out here and marking everything for C. Okay, marking everything for C. Now this was our x equal to C. Let's say this was x equals to C, and this particular point was f of C. Then you ask me, sir, how are you quantifying slope? Because this is not constant, it changes. If my point would have been a different point, if my point would have been a point here, my slope value would not have been the same. So, sir, how can you say slope? So we say that exactly this is not slope. This is the slope function. I would say this is the slope function. This is the slope function, not the slope. So I would reterm my words and saying, given a function y equal to fx, if I want to find its slope can be at a particular point. So before that, I would find the universal, what do you say? Universal spanner. The universal spanner would be called gradient function. Gradient function, and the gradient function is f dash x. We write it as f dash x, which is also equal to dy by dx, which is also written as y dash, which can also be written as limit of h tends to 0, f of x plus h minus f of x divided by h. This is the gradient function. And now you may ask me, what is the slope at x equal to c? I would say just plug c at the gradient function, you get slope at c. And I can also write it as dy by dx at x equal to c. Or I can also write y dash at x equal to c. This is the concept of slope of a function. Slope of a function cannot be one value. So when you find out the slope of a function, that is known as the gradient function. It's the gradient function. It's like a mold you have found out. On that mold, you want to make a chocolate cake, make a chocolate cake, vanilla cake, make vanilla cake. X equal to, sir, what is the slope at x equal to d? What is the slope at, sir, what is the slope at x equal to d? You find out, you put f dash d, finished. And this is known as, given a function y equal to fx, and they tell you differentiate y with respect to x. WRT means with respect to x. You say y is equal to f dash x. This is what you're trying to find out. Sorry, not y equal to f dash x. You're trying to find out differentiate with respect to x means they're asking you find out what is f dash x. They're asking you, or find out what is y prime. The same thing, or find out what is dy by dx. They're asking you the same thing. That means you say, sir, dy by dx, also known as derivative of y with respect to x. So how do you read it? You read it like this. See, again, once again, you read it as d by dx of y. You are differentiating y with respect. Don't write straight away, read as dy dx. That way you'll read later on. But you're differentiating y with respect to x. Okay, you're differentiating y with it, which is equal to differentiating the function with respect to x, which is equal to the derivative or the gradient function, which is equal to f of x plus h minus f of x divided by h. But sir, this is delta y by delta x. Hold on, where h tends to 0. This is known as the first principle of finding derivative, which you will find in maths also. And every function, when you try to calculate the derivative, you have to calculate it in this manner. And before you fall off to sleep, just 1 minute. Okay, before you fall off to sleep, we knew that a linear function always has a constant slope, right? Linear means straight line. What did we start our whole exercise with? Sir, we started our whole exercise with straight line. Straight line means constant slope.
Mm-hmm.
Very good. Start adding little bit of coordinate geometry. Straight line means linear function,
Mm-hmm.
right? So let's take
Yeah.
a linear function. Fx is equal to 3x plus 2. Let us
Yes.
try whether it's slope. That means if we try to calculate dy by dx, we should get something which should be constant. Then only we'll say slope is constant, because this stands for slope,
Mm-hmm.
right? So let's put our idea. So let's calculate limit of something, say h tends to 0, f of x plus h minus
Mm-hmm.
f of x divided by h, which would be equal to limit of h tends to 0. Now f of x is 3x plus 2, f of donkey is 3 donkey plus 2, f of monkey is 3 monkey plus 2, f of x plus h is 3 into x plus h
3x plus h
plus
plus
2 minus f of x again. So 3x plus 2, this is f of
Mhm.
x divided by h. What do you land up in? You land up as limit of h tends to 0. It's 3x plus 3h plus 2
Mhm.
minus 3x minus 2, right?
Yeah.
Happily, the 3x and the 3x takes away, the 2 and the 2 takes away, right? And you
Yeah.
also have a h in the denominator. So our next step would be limit of h tends to 0, 3h by h, and the h and h go away. Now we don't need to plug any limit. The value is 3.
Yeah.
Constant. It's constant. That means
Ah.
3 is constant. You don't have a variable with it. So you
Mm-hmm.
have proved that the slope of a line is always constant. Nothing more today beyond this, because after that you'll puke.
Mm-hmm.
Defense rest.
Yes, I got it.
Now you,
Because like on a linear function, it's like y equals mx plus c, and m is the
M
slope.
is the slope and c is the y-intercept. Yes, girl, you're getting it.
Ah.
That's why it's, if you know the slope and the y-intercept, you can construct a straight line. You don't have such type of a formula for any curve.
Mm-hmm.
Because in curve, m is never constant. How can you have a generic formula?
Mm-hmm.
Only in a straight line. I was about to come to that in our next class, but I was happy that you got extracted from your mind. So today we loved about the lovely necklace from Mendeley and pearls from Mendeley, and then this is known as the first principle. So given any function, if you want to find out the derivative, this is the way. But again, this is when you are doing it with a hand grinder. But you are a good girl. We will give you a mixie in our next class. We'll give you some formulas. But when you start calculus, they'll make you go through this grind. Every function that they ask you to differentiate, they'll ask you to differentiate from. This also is known as the first principle of differentiation. Everyone has to go through this grind. But you will go through this grind in your maths class. Since we will be doing physics, I will give you the mixer grinder before that.
Okay.
Although you know this now, but you will differentiate with your ideas. So what did you learn today? Basic of slope of a line. After that, you learned a basic concept of limit. Then you started interpreting. And when we talk about differential calculus talks only about slope, slope, slope. Integral calculus will talk about area, area, area. Now go back to class 9 motion chapter graphs, where I used to yell out of my throats and you all used to pay the least attention, and I used to tell you, find the area of the graph, find the slope under the graph. Integral calculus, differential calculus. Integral calculus, differential calculus. So differential calculus always hovers around one topic. If in short somebody tells me, sir, what is differential calculus? I would say, given a function y equal to fx, in differential calculus, you are only interested to find the slope. No, not exactly slope. If you're interested to find out what is the gradient function, that is f dash x. That is dy by dx. This is your own soul. So if you like the class, you can press the like button or smash on the subscribe to make us more, rejuvenated. And
yeah, don't forget to ring the bell so that you get notified for every new upload.
Yes, don't forget to click the bell icon so that you get notified every time the demon appears on the channel or the demon has posted something new. And also hit and smash the subscribe button before you go, because that motivates us to make more videos of this order. Until then, there was no sponsored content in this. Whatever the views are, the views and disclaimers are, they are all our own, and that's why the story of that blind lady and everything is our own story. And you can also have one more icon of Rotten Tomatoes. If you don't like it, you can smash the Rotten Tomatoes, obviously on the PC purchased by you, not on mine. And so that. So can we call it a day or a night for you? Right. Thank you. You
Absolutely.
can note down. I'll send you the video. Now you have no more stamina to even copy it down, right?
Yeah, I'm done now.
That's what I wanted. Yeah. Chalo. See you again in our next class. And until then, so but please read till this much. Then only.
No, absolutely. I
Read
will.
and have your question sets also ready. Until then, dinner over or yet to be done?
No, yeah, dinner over. That's why I'm extra tired.
Okay, so now you need to go and crash on the bed.
Bye, sir.